Respected faculty members, today I am here to provide you the important guidelines regarding DPT1 in phase 2 session. In DPT1, you have to make students to prepare magnetic effects of electric current. Magnetic effects of electric current. One, this topic covers the important facts that electricity and magnetism are interconvertible and how we are exploiting this effect. These aspects are covered so far in this particular session. So the first and foremost thing you have to care for thorough quick check summary. Quick check summary should be thorough. Quick check summary. Later, you should concentrate on concept buildup. So in this concept buildup, you should make every student familiar with what is magnet. First thing, what is magnet? It is a metal bar with two poles, north and south, and also it attracts iron, cobalt, nickel-like materials. So that is called as magnet. How can we come to know it has north and south poles? When it is suspended freely in the air, directive property. Any magnet upon suspending freely in the air by means of a thread, you will come to know that it will always come across pointing the directions north and south. Geographic north and south directions. So, geographic north and south directions, east and west. You know very well. So, every magnet will have directive property will follow and it always come to rest when it is suspended freely in north and south direction. Why? Why this magnet is behaving like this? This aspect is also to be made clear. Number two, this replicating this effect, what you call it as directive property, mankind has exploited this to indicate the directions by preparing a compass needle. Compass needle is a glass envelope containing a thin metal wire, magnetized metal, that is which can freely rotate about its axis, is enclosed in a glass casing, which is used to indicate directions at a given place. What you call it as magnetic compass. Magnetic compass. And you have to familiarize other important thing, magnetic field. What is magnetic field? This aspect is also to be familiarized. The region up to which we can feel the influence of a magnet is referred as the magnetic field. So around a magnet, up to some extent, we can feel its influence. That can be demonstrated by just spreading the iron fillings. Iron fillings will align themselves from north to south along a curved lines traveling from north to south. Or using a compass also, you can plot the magnetic lines of force. So lines of force, what is the line of force? That should also be made clear. The line along which, the curved line traveling from north to south, along which the magnetic influence is felt, will be referred as the magnetic line of force. So why it happens? Why suspended bar magnet always turn north and south? These also should be made clear. You know very well, this Oersted experiment. After Oersted experiment, people came to know that a conductor wire, any copper wire, made to pass through a thermocol sheet and now connect it across a electric cell, key and ammeter, and this connection is made. When the key is connected, the compass placed near the conductor, when it start carrying the current, immediately started deflecting. Compass placed near the conductor started deflecting towards it. So this made clear, people started acknowledging conductor carrying current produce magnetic field. Conductor carrying current, conductor carrying current. What happens? It produces magnetic field. So what should be taking place inside here? From this, people made every effort to this particular consolidate this effect. What is that? Earth. If you go into the earth, deep into the earth, there is upper surface that is called crust, earth crust. Internally, there is a mantle. Mantle also will cover nearly 1000 kilometers, 1000 to 2000 kilometers. Inside that, you will come across the core. This core is entirely made of iron, which is at 6000 degrees temperature nearly. Above this core, the mantle is made of nickel, mostly nickel and magnesium are present, which is molten state, will be at nearly 2000 degrees temperature. When two metals are joined and the junctions are provided with temperature difference, then current will be produced. This is the very, very interesting fact that you have to carefully explain to the children. What happens? What you call this as thermoelectric effect. Thermoelectric effect. What is thermoelectric effect? When a metal couple, when metal couple is joined, two metal wires are joined, and the two junctions are subjected to different temperatures. Iron, copper. Take iron, copper wires. Iron and copper wires. Join them. The two junctions are subjected to temperature difference. One is kept at 100, another one is kept at 0. Immediately, the current will be produced. This is what you call it as thermoelectric effect. You can try with any type of couple of metals. Two metal wires are joined and the couple of junctions produced are subjected to temperature difference. Immediately, the metal couple will attain the current flow. Current flow will be taking place. What you call it as thermoelectric effect. The same effect is carried inside the earth also. Between core and mantle, we have lot of temperature difference. That there is a metal couple, iron nickel. Obviously, there will be lot of current will be prevailing inside the core. Lot of current will be taking place inside the core and mantle. Lot of current flow is taking place. What you call it as thermoelectric effect. Whenever current flows through any material, what is the result? Some magnetic field will be produced. We can sense the magnetic field producing around. Current carrying conductor produce magnetic field. Obviously, around the earth also, lot of current is prevailing inside the earth between core and mantle. Therefore, lot of field will be produced around it. That is why earth is behaving like a magnet. This information is to be carefully provided to every child. That is very, very important. So here, what is magnet? What is its properties? And how we are exploiting the compass? For what say compass is useful? What is meant by magnetic field? How this magnetic field is exerted? And finally, why compass is turning towards north and south? That should be made clear. What is happening inside the earth? Thermoelectric effect is taking place. What is thermoelectric effect? When two metal wires are joined and the couple of junctions produced are subjected to temperature difference, obviously current will be generated. This is what you call it as thermoelectric effect. So using this effect only, inside the earth, lot of current will be taking place. Therefore, magnetic field is producing. You have to make this point clear to every student. Why earth is behaving like a magnet? Because lot of current is prevailing inside the earth between core and mantle. So this magnetic field will, what it will do? when when a bar magnet is suspended freely, obviously it will be caught by the earth magnetic field and made to deflect towards north and south. And the important experiment in this aspect is what made this point clear, that is conductor carrying current produces magnetic field. Later we demonstrate this field is circular loops. Closed loops are formed around the conductor carrying current. Using a compass, we can plot the magnetic lines of force around a bar magnet. That activity should be made clear. Give the students proper practice in plotting the magnetic lines of force around a bar magnet. After that, you have to show the directions. How can we get the direction of current traveling? This is again Kramer's principle. So, by which can help us to lead to the condition to the consequence. When current is flowing through the conductor, what will be the direction of field? This can be easily monitored by the hand rule. Take a right hand thumb rule. Take right hand, stretch the thumb along the direction of current. Then the curved fingers indicate the direction of field produced around it. So this rule will help us. Same manner we have many other rules also prevailing. What are those? Maxwell corkscrew rule. Maxwell interpreted the same result with other technique. What you call it as corkscrew rule. He asked us to imagine a corkscrew is fixed in the direction of current along the conductor. If you want to fix the screw in the downward direction, how you have to rotate its head? That will indicate the direction of field produced around it. So this link is to be carefully established, and finally you have to give practice of those 4 important experiments. Oyster experiment, and number 2, magnetic lines of force. How magnetic lines of force are produced around a conductor carrying current by sprinkling these iron fillings. That is second experiment. We have to prove closed loops are formed. And third one, direction of field resulted can be interpreted by using either Maxwell corkscrew rule or right hand thumb rule. Right hand thumb rule. These 2 are to be carefully make the student to learn. So after this particular aspect, we will go to this force acting on the conductor, that will be in the DPT 2 part. So please take care of first part, quick check summary, second concept build up, establish the fundamentals, and give the student a proper clue to make and understand, to analyze and understand all these aspects. 4 experiments are to be taken care of. Conductor carrying current produce magnetic field. Number 2, we have to make a conductor carrying current produce closed loops by sprinkling iron fillings. That is second experiment. And third one, how to get the direction of field produced around it. And fourth one, we come to in the next session, that is 4th experiment and 5th experiment, will come to the next session. So please care about these all important aspects. Later give the students proper practice of changing the question into different academic standards. That is third important aspect. Fourth one, ask them to write as it is given in the material and quick check summary, and ask them to avoid writing whatever not given in the material. So, and finally suggest the youngster and this spark children providing the correct suggestions and making legible evaluation. Thank you very much. I wish you all the best.